Hello everyone, my name is Simon, and today I'm going to talk to you about Clojure.spec, which is a Clojure library and also a sort of type system a la carte. But mostly this talk is going to be about some of my thoughts on how can we imagine a type system that follows the uniqueness of a dynamic language versus what we're used to from statically typed languages. So now, every time I speak at a functional conference, I feel a bit like this cat speaking about like a dynamically typed language when everyone else has this profunctors and arrows and category theory, and we have map and filter, and we're quite happy with it. But at the same time, there is certain prideness in being a Lisp developer, but I am also aware that not all things are great. But I think like many of the problems that Clojure is facing are also kind of more widespread. And all of those problems were also sort of part of the motivation behind developing spec. So let's look at a couple of them. One is just a question of communication. Now, documentation is a fantastic thing, but at the same time, it's also usually not enough. It has those obvious problems that you always have to keep it maintained and up to date. And especially with languages that kind of don't have a very rigorous type definitions, you also have to then basically describe your types in prose with your documentation, and that's again kind of very brittle. So we're looking for a better solution in terms of just how we communicate the intent of our code. Then the second one is that kind of error handling and reporting. And this is, I guess, like a sour topic with most languages, and Clojure is especially not very good with it. There are some bright examples like Rust or maybe Elm who do a lot of interesting things in terms of what can be done with error reporting, but still I think even there they have a lot further to go, especially once we start also to think about that maybe we'd want to have like structured errors that we can then interpret in some way and so forth. So again, another area where a lot more can be done. Then in Clojure specifically, a lot of computation is just kind of described or encoded in just naked data structures, meaning just some configuration of nested maps and vectors and so forth. And kind of working with that, on the one hand, like Clojure is rather good at doing it, but at the same time, it does also pose some problems because, again, you have to be very careful with specifying on what kind of data structures you're operating or not. And again, this can be sometimes a bit problematic. Then we have generative or property-based testing is something that's kind of becoming more and more in vogue, and it's kind of a lovely thing. So why not throw this into the mix as well? And last but not least, manual parsing is something that we often do, even for like those various half-hearted, poorly specified languages, but we kind of do it on a day-to-day basis. And it's also something that's quite tedious and error-prone. So having a better system to that, again, would be a huge win. And Clojure.spec tries to solve for all those problems, please kind of provide a building block to then building our solutions on top of it. Basically, it's based on this paper called Parsing with Derivatives, where the idea is to have this functional approach to parsing using regular expression derivatives. But it does add some twists to it. The first and most noteworthy twist is that instead of just parsing or working on strings as regular expressions usually do, Clojure just generalizes this to working on arbitrary data structures. Then the second thing it does is it introduces the ability to have arbitrary predicates. Basically, you can have any kind of Clojure code running within your spec. And last but not least, it also provides a mechanism for transforming data as you're kind of validating it. So let's have a very quick look at how this looks in practice. Now, I'm not going to walk through all of this because I don't think it's kind of, that important. But the main point of it is that, as you can see, there are some things that you might recognize from regular expressions, and then we're also mixing just kind of random predicates and even some transformations and so forth. But as I said, this is mostly just for you to get a taste of what spec actually is. And it's also it's one of those libraries that very well encapsulates this core Clojure design principle of trying to get to the bottom of things, decomposing them as much as possible, find the underlying structure, and then build on top of that. Now, a great library example of that would be Clojure Async, which copies the Go coroutines and brings them to Clojure. And what happens is when this is done right, it feels like it has been a part of the language since day one, even though it's something new. But what I most want to talk about is the Lisp specifics, or at least dynamic language specifics. And this, for me, in a lot of ways boiled down to essentially this notion of having a very live programming environment and a very live programming experience. And like with Lisp, and probably Smalltalk would be another example of this, like one of the, I think, core distinguishing features is not that much macros or something like that, but rather this idea that Lisp essentially runs in the same context it's written in. So you don't have this clear delineation between your environment, your type checker, your compiler on the one hand, and your code actually doing something, but rather just kind of this continuum between the two. So you'd often see that people using Lisp to solve a problem will actually also kind of be building tooling around this to solve their problem. So we're not just using the language to solve a problem, but we're also shaping the environment in which we're doing this towards solving this problem. And spec, again, I think is a great building block in doing that. Because it does kind of bring some more, or maybe some bits where we're currently lacking in Clojure in terms of what we can do with type checking. We get some of those benefits, and also what I find interesting is that you can use it in so many other ways. So what follows now is going to be just a whirlwind tour of some of the things that I find kind of interesting or kind of unobvious consequences of the design choices that went into spec. First, in that it allows kind of destructuring, meaning kind of pulling apart complex data structures and name just some constituent part and using that. And why this is great is that because just in terms of how you can organize code, because you can now separate the part where you're transforming your data from the part where you're actually doing something with it. And I find this is very helpful in just how clear the code is, because when I want to just think about the flow of data, and what processing is going on, I can just focus on that, and you don't have to think about all the kind of essentially boilerplate of just transforming data from one form into another. And this kind of spec allows you to pull those out and just have the definitions, which at the same time are also kind of transformations for data, and you can then separate the two concerns. But sometimes you also just might want to understand the glue parts of how code gets transformed, and again, at those points, you don't have to think about processing, but you can just focus, okay, what's happening with my data as such. The next thing is some things like so-called data macros. The idea is that we have this kind of recursive transformations of data into some canonical form. And it allows us to do more without using code macros. Now, the code macros are one of those highlights in a way of Lisp, but there are also some they can be very powerful, and they're a great tool to have, but oftentimes they shouldn't be used because they do introduce some problems, especially when it comes to things like a functional composition and so forth. And the kind of data macros are, I find, a great alternative to this, because you still have all this kind of power of transformations, but at the same time, you don't have the penalty that the code macros bring. And the idea is that we can provide various kind of defaults and different reshape data, and it's just kind of self-transforms and does this in a recursive way, so you don't have to, if you have this kind of complex nested data structure, you don't have to start at the bottom and kind of think about all the possible permutations of your tree, but just kind of start at the leaves and define just a transformation for those, and the spec mechanisms will do the rest for you. So just for instance, like example, we want to have this kind of a nice, clear DSL, and this is all just kind of data structures. But at the same time, if you look at the 3 different clauses, they're quite different in their shape, and for the rest of our library, we want to have this kind of a unified way of handling them. And what spec can do is to kind of transform this into this much more computer-readable and unified form, but which would be terribly, terribly tedious to write. So we can kind of have archaic and easy to in terms of that we can define a very clear, nice DSL, but at the same time, we also can have a form that's relatively easy and straightforward to work with within our library. Then it's kind of continues this notion of separating dealing with data from your actual processing code. Is that also kind of decomplex validation and encoding from the rest of your code. Again, like if you look at your code, one of the biggest points of boilerplate is going to be just the spots where you also need to think about all the various error handling and exceptions and so forth. And spec is kind of a step towards, again, separating this two and allowing you to just think about processing and then kind of have validation as something completely separate, which is, I guess, the same thing you would get in a statical type system, but here it's done in a completely dynamic manner. And then we have generative testing, which kind of, we already know that at school, I think it's going to be a longer talk on this as well, but it does also kind of bring interesting things that are just the Clojure way of doing it. For instance, like you can have bare mocking in the REPL by just generating some data and using that as you play with your solution and developing it. And last but not least, everything is data. This is, like, again, one of those fundamental Lisp things. And this allows us to generate spec on the fly with our program. It allows us to do kind of various introspection And as I've mentioned previously, we also can have parsable errors and like machine readable errors, which can be very powerful in terms of doing automation. And there are already people building interesting things on spec. I'll just kind of mention 3 of them, which I guess are interesting to the audience here. One is like there is a project which tries to do static analysis of spec-annotated Clojure code, so really kind of emphasizing this part of spec being a type system. And then there are 2 ways of kind of people trying to infer spec, either from examples or taking a test and then transforming it back into spec. And I'm very excited about the possibilities that the spec is offering, and I think that we're just scratching the surface with what can be done in kind of when you have a type system that is, in a way, kind of available to you during runtime, and how we can think about doing that differently. So kind of to sum it up, a couple of main points, like try to decomplex as many things as possible, like don't have different concerns at the same place, and try to find tools that really enable you to do this and are actually kind of become idiomatic to kind of separate all those concerns. Then everything kind of that could be, should be live, and it should be interactive. This allows this, I think it just makes it a much better developer story, and also allows you to kind of build tools on top of that. Especially if you kind of go all the way in terms of what a dynamic language can bring you in this blending between the environment code and your work code. And last but not least, if you put all those things together and couple it with having everything more or less described as data and having it available as runtime, this is an amazing building blocks and then build on top of that and building different tools, because everything is accessible, everything is queryable, it's just data that you can then kind of manipulate it, generate new, and this actually changes your running code, changes your environment, and allows you to build tools on top of that. So track me down if you have any questions. It's quite obvious. I love to talk about this, so, and thank you for your attention.